It's a kind of, what I'm going to tell is a kind of history about to try to beat infection disease and how we have changed this strategy. But I will try to go through history in order to show you some heroes of mine, people from Catalonia actually has been doing a lot of research on. And I will start with this guy. This is in my signature in the Gmail, which says, "Go ahead, Salvañ, you are a hero." This Salvañ was a guy that, this is a measles, this, you know that the vaccines comes from the virus vaccinia, that is the smallpox in cows. So in the beginning of the 19th century, in Spain decided to make this philanthropic expedition to go to South America to vaccinate all the South Americans. And the idea was that they vaccinate little children, and then they vaccinate all the children and make this spread of the vaccine through the liquid of the papula that made after the inoculation of the virus from another papula, etc. You know that what I mean is this: the smallpox makes a kind of papula. Yes, exactly. So this was the Balmis expedition, and this guy was Salvañ was a guy that was a military. That was we only know about this signature. He was studying medicine in Barcelona, in the Academy of Barcelona, and he became a military because usually at that time the doctors were, well, the physicians were militaries. So he realized about that and he joined the expedition, and this expedition started from Galicia in the beginning of the 19th century. And he joined because he was his health status was really bad. He had tuberculosis, it was spitting blood, and he had malaria and got diphtheria. So he thought that this kind of travel trip could be very useful for his health status. So he go there, but then Balmis at such a time, he decided, well, you go to the south, and the guide was to the, he sent Salvañ to the south, and so he had this problem with the fleet. It was a, how is a naufragio? Is a sink of the ship. So well, but anyway, so the idea is that he went to Cartagena de Indias, then he went to here to Quito, he started to spit blood, but so the guy he went to Caracas, so then to Popayán, so this massive blood. So then he went to well, through the Andes, going up and down, you know, with his 5 children. Of course, every time were different children, but going up and down. So he broke his arm, then he got an injury on his eye, he lost one eye. So the guy was spitting blood and stuff like that. So he tried to stop all the time. So he went to Lima. He got 2 doctorates, 2 PhDs at the time, because it was the only university in the Spanish Empire that could have this doctor. It was in South America, not in Spain. So, because every time he tried to stop this, so he said, well, I am in very bad shape. I will try to rest here. Please give me some, you know, some position in the embassy or whatever, and I will be there and I will keep there. So they say, no, Salvañ, you are a hero. You go ahead and you go with your enterprise to save life and so on. So finally, he was robbed here in the Andes again. So he went to the La Paz. So he asked to be intendant, then regidor of the council, and at the end he died in Cochabamba because of massive tuberculosis. And well, it was that bad shape that even we don't know where is his tombstone, because there was an earthquake that engulfed all the church. So this is one of the first heroes. You see the second one, you can turn this more international. Louis Pasteur, he made this theory about that infectious diseases were well, started by a bacteria, a pathogen. So they make this fantastic experiment in which he just boiling culture media with this kind of fancy and you could not be infected because usually this could not be infected because the entrance of the pathogen just rests in here. So when you cook this, and then you have this infection. This was a nice theory. So this was the beginning of the pathogenic theory. So this is the first vaccine that was therapeutic. This was with how you call this, a spinal medulla, spinal cord, exactly, from a rabbit infected with rabies virus. So this is, well, he started with the vaccination, but with a real vaccine, so making a kind of attenuation of the vaccine, and he started the world of vaccines. Here we have Robert Koch, again a little bit more younger. He also he discovered the origin of the infectious because the idea was that one infection should be this thing that you got from the place of the disease. You got a sample, you inject to another, you can culture that in a plate, you can isolate, and if you infect another animal, you get the same thing that in humans. So this was the very beginning of the germ theory of the infections. So this guy got in the 1882 was the first to demonstrate that TB, tuberculosis, was made by a bacilli, so by a pathogen, and also make this announcement just 10 years after of a cure. This is very interesting because there is a book, a novel on that. There was Sir Arthur Conan Doyle, you know, Sir Arthur, the writer that made Sherlock Holmes, was at that place because he was a doctor. So he was doing a tournée in Europe. So he was in Berlin and looking at this announcement to have this remedy against TB. But the remedy was not that remedy because it was not this salvation thing. It was just the use of a vaccine, again, a therapeutic vaccine, using the bacilli of tuberculosis, kill it, and, well, in a way, purify it, and given in certain doses to the ill person, so the person that had active TB. So it was very much criticized because it had not expected outcomes. And in a way, all his enemies went against him, and he tried to, also the government. So they wanted Koch to be the director of the Robert Koch Institute, a kind of medical health institute in Berlin, like the Pasteur Institute in France. And he wanted to develop the tuberculin. So he was one of the first entrepreneurs that were killed because he wanted to develop a product, but the government did not allow him. So they catch the patent of him, and he was the director of the Robert Koch Institute, which is still running. So at the time, then he was, Robert Koch was discovering every kind of disease, infectious disease, and was constantly traveling. And at this time, he identified the cholera bacilli in Calcutta, but he was not the first that made a vaccine against cholera. The first one was a Catalan one that went to Marsella, that was also epidemic of cholera, and got some samples from ill people with the disease and carried through the border. He was stopped, and he said, "Well, you cannot carry that product with you." So he was put in jail. So at the end, he smuggled, putting one of the samples in the shoe, and could go through the border, and went to his lab and made this first vaccine. That is the first choleric vaccine was made by this guy that was Jaume Ferran. It was a kind of a genius, a local genius from the south of Catalonia near Tarragona. This guy was a kind of genius that made this first telephonic line from, well, probably in Spain. It was the first one. And also made this emulsion that 10 years after tried to patent Kodak. But they could not because somebody else said that this was already published. So this is a typical thing. So at that time, it was also the case. So he was the first director of this Barcelona municipality lab, where they started to make this vaccine against rabies that was made by Pasteur. So you see here vaccinating people, and also getting this serum against that tetanus and diphtheria that was also discovered at that time. So here, just a little homage to another person that was a pupil of Robert Koch, which was Paul Ehrlich. This was probably has discovered everything in microbiology. It was the guy that made the first drug against a disease, infectious disease. It was the sarbalsan against syphilis, also against malaria, and also against Chagas. But the problem of this guy that also discovered the idea of the antibody against, the use of antibodies against, to make an immunity with antibodies to control infectious diseases. This guy make these patents for having this serum therapy, the use of antibodies to avoid diphtheria or tetanus. And the problem of this guy is that he wanted to be also director of an institute, of a research institute. But so had this patent, and there was this guy they usually put both together, this Bomb Behring, that they shared the patent. They wanted to make this company together. But Behring said to Ehrlich, if you want to be a director of a public institute, you cannot have shares of anything. So if you give me the shares, I will help you to be the director of this institute. So the guy, Paul Ehrlich, gave the shares to Bomb Behring, but he was not the director of the institute, of course, because he didn't help him, and because Paul Ehrlich was a Jew. So a Jew could not be a director of a public institute at that time, apparently. So this Bomb Behring, that is the origin of the Behring-Mannheim institution. This was the bad guy of the film, because also was intriguing with Robert Koch to get the patent of the tuberculin, and something that apparently was failed, but it was used for a long time. So coming back to Ferran, this guy was at the end was fired because, well, you know, in this political intrigations. Still, there is the lab in Barcelona. It's interesting. His lab is still now is a nursery for children. It's interesting. So this guy at the end started to work with a vaccine against tuberculosis. So you see here with the king of Spain. So here he started to work with the theory that the tuberculosis bacilli had this kind of cycle. So he identified this a form of this cycle, life cycle of the bacteria. They call it alpha. So he started to make this vaccine, anti-alpha vaccine, that was against tuberculosis, made by these extracts of this special form of the bacilli that he could identify. So it has some utility at that time, and even it was criticized, but then this was followed by another guy, was Conrad Chalabardet, that started to study also this cycle. This is something that still has people is working on that, because it's something not solved at all. But anyway, there was another pupil of this guy, this Ferran, that was Raballat, that also working on that cycle, and make this, identified another form of this cycle that could be useful to stop the progression towards active TB, and make this first. He was a veterinary guy, so he make these first studies near Girona, in Salt. Studying that with cows mostly. And, this was not very well diffused, scientifically speaking, because he was a veterinary. But there was another doctor called Raballat, called Pla, which was a doctor that This is the doctor that started, well, it was started in studying Barcelona, etc., etc. It was in the, with Ramon Turró in the municipal laboratory of Barcelona. And this guy took this theory, making a kind of serum therapy like Paul Ehrlich against tuberculosis, and was very successful. So this is the Institute Ravallat, Pla, because the guy was Pla and the theory was Ravallat. Ravallat, at the time that the institute was built, he died because of cancer. But this building still is there in Barcelona. It's a fantastic building. He had a lot of horses to inject this form and make this serum to make the treatment of TB people. This was the medicine, and so this was working until the 80s, so the 1980s. This is fantastic. This is a serum therapy against tuberculosis. He has a lot of success especially in South America, in Belgium and Portugal. He had a very nice dissemination. You see here, this is a kind of congress in Cuba where he make this, this conference or whatever. They make this kind of booth, kind of primitive booth in a congress. So you see here how successful it was in terms of the doses that he could sell through Europe and also through South America. He had, there was the Civil War. This was a Republican guy, so he left. So his daughter was the one that was also a physician. So was the one that after the Civil War was ruling also the institute. So this person, I was not lucky enough because I was about to talk to her because he just died 2 years ago. It was a pity because we don't know exactly. This is a fantastic story because after the anarchists wanted to kill him because he was a Republican and was a wealthy guy. So he left to France. He tried to enter again, but then the Frankists wanted to kill him because he was a Republican. So the daughter was also in the Franco part, and so he could escape. Well, anyway, the idea. This is really a novel story. So going, what is it? Okay. So going further, so this is another guy, a very important one. This is Salé, also a very good physician. That was the one that introduced the vaccine against TB that was made in the 1924 after the Ferran one, that was used also having this attenuation bacilli of the cow. So it was a kind of copy of the vaccine that made Jenner, using the model of the smallpox of cows. So he was one of the first that introduced this vaccine and was introduced it in Barcelona, as any other cities in Europe and in the world. And but the problem of this vaccine, that has been the one that has been used for longer, among all the vaccines, is that only protects children. It does not protect people to be infected.
For what reasons? Why in children it works and not on adults?
Children to have a mortal disease. So you can be infected and develop a lung disease, but this gives you some time in order to, giving this immunity, it does not prevent you to be infected, but it prevents you to have a massive infection and to have a meningitis or a disseminated disease, which is what used to happen in children. But this didn't avoid the infection and didn't help too much to control the disease, but actually has been the vaccine that has been more used in the story of the medicine, like it has been given 2,000 million of doses so far. So this was Pere Domingo, that was after Ferran and after Turró, well, also dealing with the laboratory, the Barcelona laboratory. This was the guy that made BCG from them. You see here the guy. You see here another person, very important, Francesc Duran y Reynals, that was very important we have a hospital here, in the cancer therapy. I will tell you why. And this is joking because He used to be the model of the, this you see up on the donkey in the laboratory, outside of the laboratory with Pere Domingo, and it was like that because they were joking all the time, because he was the model, this scientist was the model of St. George, that is in Barcelona, in the Montjuic mountain. If you ever go to the Montjuic mountain, you will see this guy is a scientist, a good, very good one actually. So the guy also with the Civil War left to Cuba, and he was the one that made this vaccination through ice, through ice cream. So they make this interesting vaccination of children, giving orally, putting the vaccine in ice cream. So he vaccinated at least 60,000 Cuban children. This is very interesting. So jumping now from there, from all this history, you can see this guy that has been very revolutionary guy in the University of Barcelona in the vaccination against papillomavirus to avoid the cancer. This is about the theory that made Harald Zunhausen, and this came from the theory of the cancer induction that was first studied by this guy that was in the model of St. George, that was Francesc Duran y Reynals. And that this was the origin of all the antiretroviral therapy against cancer that was done in the 60s. This guy died at the end under 55, but it was his lectures. He was in, of course, he left with the Civil War, he left to the States. But these drugs did not help people against cancer, but did help against AIDS. So you know that AIDS people now are treated thanks to these antiretrovirals that were made on the 60s, because the USA government decided to trust this guy, and others of course, to try to kill the cancer with his antiretrovirals. They did not succeed, but they use it for AIDS. So this is a very interesting thing. So here we came with Fleming. This is why Fleming, because this was my hero. You see here me, this is me when I was young. Well, much young than now. So I was really fascinated by this guy. This is very interesting. You know that this guy. Why you know this guy for what? Fleming. Dr. Fleming for? Penicillin. Okay, remember that. No. This is important. Remember this image, and remember this is penicillin. This is Fleming. Okay, I thought like that that time as well. So you see here that I started my work doing some work with the Cardona River. That is I am from Manresa. This is a tiny city inside the inland. This is a river. This is very important as well. So I started to do my work before to go to the university. So I was a kind of freak at that time, an old freak. So at that time there was another important thing, that was the vaccine against malaria made by Manuel Elcín Patarroyo, the first synthetic vaccine. So they built the peptides artificially. So this was a revolution. So this guy was not even a medical doctor. He was just a freak that worked a Colombian guy that went to the States and did that for fun. And in Barcelona, it was Pedro Alonso and Clara Menendez that helped him to do the clinical trials and have this kind of relevance. At the end, it's not that good vaccine, but now the one that seems that is going to come is not that better than that. So the problem of the vaccine of Patarroyo was that they made the batches had not quality. So sometimes it worked and sometimes it didn't work. It didn't work. So this is a problem. So it was a quality problem. So at the time, I entered, even when I had this idea about Fleming and about to be a microbiologist and so on, I came to this TB. You know, TB has killed already 1,000 million people. So still kills every year 1.5 million, mostly 1.5 million every year.
And especially from?
Especially in India, China as well, but also Africa, because of AIDS, the combination of AIDS. So TB is transmitted by air, so it's very difficult to know who has infected you. The other day I was talking to somebody that I was talking to a taxi driver. What do you do for working? I say, well, I work with tuberculosis. You know, I had a friend that had tuberculosis for a it was treated for a long time and so on. I say, yes, I know. Yes, the guy that was working as a waiter in the Ritz. So this guy probably was infecting a lot of clients of the Ritz. Yeah, it's like that. I mean, it's impossible to know.
But since these locations, especially, so does it mean that in the industrial world where they're vaccinated?
No. But the vaccine, it does not, only helps children, heavily infected children.
So how come they just don't, they don't immune in this part of the world?
Well, of course, they do immunization, but this does not help adult people to develop the disease. That's the main problem. In a way that...
How come you don't have, in the industrial world, you don't have...
Well, I will tell you why. You will see that...
We are citing too because of immigration, no? There's been recently some more cases in Europe.
Yes, it's immigration, but in
Coming from this area.
Yes, but in Spain especially has never been totally clean. I will tell you why. So in Spain we have more or less the 60% cases are from Spanish people and 40% from, but still it has a really wide dissemination. And also the capital of TB in Europe is London. London, they have a lot of TB in different quarters. So yes, is a problem. People from Pakistan. So the thing is that not is the immigration, is because these immigrants they come back and come again, and so that's the movement is quite difficult. So it's.
The question wasn't clear, I think. If the whole world is immune, how come the disease is only in these places, or especially?
Because the whole world is not immune.
It's not immune.
It's not immune.
There is the vaccine, but I tell.
Immune, I'm sorry.
The problem is that the vaccine does not avoid the disease in adults. Only helps children, neonates, to develop really disseminated disease. Only neonates. I will tell you why. Because, well, I will tell you why.
Okay.
Because this is when I come to the stage. So this was my old boss. So I started to work in microbiology because I like it. Fleming was my leader, my idol, but of course Fleming was not working with TB yet. So I started to work as a specialist with this guy. So this guy was working in TB. So he sent me to the Colorado State. You see here, at that time, 20 years ago, with Ian Orme in the Colorado State University. The guy was from London. So this was my thesis. So what I saw in my thesis, and this is the origin of the one spin-off, was that the bacilli escaped constantly from the lesions and made lesions constantly in an already infected person. This means that even when you have the best immune response, you cannot avoid to be infected again. Why? Because the lung is like a tennis court. It's huge. So if you infect just one cell of the lung, nobody cares. The lung is a place where you have exchange of gas, so there is no inflammatory response usually. So you can infect constantly the cells that are in the lung, that the alveolar macrophages. So but at that time I discovered that it was all the contrary that it was written. So at that time was like, once you have this lesion, the bacilli cannot escape from this lesion. So what I saw with my eyes, it was the case that was escaping because these macrophages, these cells become older and carry the cells, these bacilli out of the lesion because the bacilli did not grow anymore, and it was confused like to be a kind of dead thing. So and just escape and make new lesions and new lesions. So this was the origin of this concept that you can be reinfected, you make this lesion, you have the immune response, but the bacilli can escape and can reinfect you constantly. And you keep, because one of the characteristics of the infection, TB infection, is that you can be infected for years. Even the old people used to say that once you are infected, you are always infected for all your life. So you always have a risk of having active TB, which is in our hands is not the case, because most of these bacilli that are drained of the lesion, you swallow and they just go out through the alveolar fluid, and you just swallow and they go out through the gastrointestinal tract usually. But some of them get into the aerosols and infect you another time, make another lesion, so it remains for years. So that's the point. Here is what I told you. So the X-ray, as we understand, were invented in the 19th century, but it was not massively used until the Second World War, where they started to make these campaigns with these big tracks. They put a big track in front of a cinema, and they invited people to make an X-ray to see if they had active TB. So this was the idea, that this was done in whole Europe and the USA. So they almost eradicate TB. This was not done in Spain.
So when they found somebody with TB, how did they eradicate it?
Then at that time there were some drugs in the 50s, and then at the end of the 80s there was this combination that make a short-term therapy that is for 6 months, which is still the one that we have now. The disaster is that this was implemented massively in Europe because they have this tract, they identified everybody, so they treat everybody. Not in Spain, they did not. They did in France, because there were no means here to do that. We were too poor to do that. That's the main point. So it was never this cleaning thing was not ever done. That's why in Spain we still have a lot of TB. So, and the idea was that you had, when a children has this, this was the static idea, was that you have, children has the first lesion, it calcifies, if he survives, calcifies, and then you have this, you have this when you are an adult, you have a kind of reactivation of an old lesion, and you become this old lesion made by children, because the concept was that once you had the infection, you were always infected, and the other concept was that once you had the immune response, you couldn't ever be infected again. So this was the old topic. So this was the concept, the classic view, that you have this old lesion that suddenly reactivates 30 years after or whatever and makes this lesion. And that's the dynamic view that we have seen, that this is not possible. You have constantly new lesions, and then they can become bigger in the upper lobe, because it's a special place in the lung where the bacilli can induce a great inflammatory response that make possible this lesion to be bigger, because that's the point, to be bigger, you will see. So at that time we discovered, in this dynamicity, we discovered this vaccine that was made in a way by bacilli grown in a kind of stressful conditions, imitating the status of the bacilli infecting people. And this was to be given to the drug in order to reduce the time of drug treatment. That was about 6 to 9 months. So we make our first spin-off with 2 collaborators. This is me, we got this mecenas, Pepe Martinez, and we could make this spin-off that went through this vaccine that we are still waiting for making the phase 3 trial in order to demonstrate its efficacy in the whole population. It has collaborated a lot of people. We make that from the scratch. We make a pharmaceutical from that. So this from the very beginning. This is very difficult. So you make it all. It has a lot of collaborators on that. And then we realized that we came back and we showed that Koch was not that wrong, because in a way what we are doing is something similar to that what Koch was doing. So we have made these 2 reviews saying that Koch was not that bad, even when in the whole community of tuberculosis community, they still blame Koch. And even I met this person that was an old guy looking for these TB patients, the glorious time of TB, that he say me that in in Barcelona, they give also this tuberculin. There was this lapse until the 50s, before the antibiotic therapy was already set. So even this is Salvat Papasseit, this is a poet, that he says that because of the money that his mecenas give to him, he got some money to buy tuberculins for his TB. So it was very wide used, and even when I look carefully to this picture, this was not a plate with penicillium. This was a kind of engine that made the lab of Fleming, that because they did tuberculin therapy to people, so they took blood to these patients, and they could analyze the activity of the tuberculin therapy. So this is manipulating that. So Fleming, when he discovered penicillin, was working on immunotherapy, but nobody knows that. Even not the curator of the Fleming Museum that is in London, but I got these books that on this theory, and I give it to him because, of course, this is a Fleming Museum. They should explain to everybody. You see here, this is still the Alexander Fleming Museum, and it was not the idea of Fleming, but it was from Almond Wright, which was his boss. So again, this tuberculin thing, this is my team, blah, blah, blah. This is, of course, you need a fantastic team to do that. We work still on this. But again, the problem is not the infection itself, but the induction of this huge lesion, which is the typical lesion of TB, which is the cavitation. And we discovered that this was very difficult to have this transformation, because usually these lesions are very well controlled. So we have discovered that with different experimental modeling that this can be possible, because excessive inflammatory response that makes these lesions bigger and bigger, and then once you coalesce, you are able to make this big lesion, which is the disease. And here is the origin of another therapy, a revolutionary therapy, which is that you stop this progression of this inflammatory response, and you help these lesions to be encapsulated and to avoid this coalescence, because we have identified that there are these Tregs that counterbalance this immune response, the Th17 that are the one responsible for attracting the inflammatory response to these lesions, to these little lesions. The neutrophils, specifically, the neutrophils are the cells that make the pus, the pus. So you avoid the pus to be there, so you are able to avoid the disease, and we can do that just giving this cell, the same bacilli, in a low dose, head kill it, in a low dose orally, because then you say to the immune system of your intestine that this is a food. Because this is a food, you educate your immune response, and the immune response is responsible to make more of these Tregs. This happens with all foods. So it is just to say you just lie to your immune response, and you say that this bag of tuberculosis is not that good, that bad, and then there is not this exaggerated response. But then this could be another drug. We didn't want to do that. What we wanted to do, we knew, is that you can, and that's why we make this new company, is that there are bacteria from the river that comes to the water, the tap water, that are from the family of the TB bacilli, but they are environmental. So are part of the food, because are part of the water. So we tried to do this experiment with this bacteria, and we succeed. So this was the origin of this new product, which is a probiotic. What is a probiotic? Is a bacteria, is a microorganism that gives a benefit to you, even if it's killed, because then now we know that the probiotics also kill it. Some of them can work. So this was seen because sometimes these probiotics must be kept in the fridge and sometimes they were not. So they realized that they eat it killed because they were not in the fridge. But it did work equally. So we have also seen that it works, this bacilli, alive and killed. So this is a probiotic. So now we started this. We have produced it massively with fermenters. This is not a dangerous bacilli because it's from the environmental. So you can manipulate it easily. So we have started to produce that massively, and with Mandarin we have changed that because what we wanted for the first thing is to go to the India to make, which is the biggest market where they have more TB.
For prevention.
This is for prevention. So the idea is that it does not avoid infection because it's impossible. So we don't care if some person is infected or not because we know that it's impossible to avoid that. What it stops is the progression. Now I am finishing. It's the progression once you are infected to avoid excessive inflammatory response, excessive irritation. We don't care about to be infected because they are just tiny lesions, less than, they don't grow. The problem is when they grow. If they don't grow, nothing happens. So we make this clinical trial. We see that was safe and has this immune response that we wanted. So
difficult is to do it in India. You did a medical trial in India.
No. We did the trial in Barcelona, and now we are already signed the license for India.
Because they took the trials from here. They accepted the trials from here.
I'm sorry.
The India
Yes.
was okay relying on the trials.
Oh yeah. Well, this is a food. You don't need a trial for a food. That's the advantage. The advantage here, with the difference between a food supplement, this is a food supplement, and it was their strategy, is that to go to the market, you don't need to demonstrate the percentage of efficacy that you have.
Because it's a food.
Because it's a food.
Okay.
You cannot have a health claim, but once is in the market, you can get the data. You can get the data to have this demonstration. That's the idea. So I went to India to see these people, and we have got this thing running. That's the end. So this is a nice story about you go. First of all, you go to the traditional way. You get a drug. You see the drug. One of the lessons is that you never do anything new. Usually you come back and you see that somebody else has done that in another way, but with a different technology. But I mean, it's not that new. But going further, looking at the point that this is one of the one of the big weakness of the controlling of TB, which is that you cannot avoid the infection. So facing these problems, because still there are people that say that they can do that. So once we decided, after a while, of course we have a lot of evidence, we decided that this is not possible. So we have looked to the problem with another angle of view to avoid just the growth of the lesion. So this is a very, very different. And then we got this new solution. And of course, we got another regulatory solution in order to have that in the market as soon as possible. So that's the idea.
Great.
Thank you very much.